Alright, so as usual, you should be attempting to try this problem on your own. So try it first, push pause, come back. So let's just go ahead and sketch this problem out. So essentially what this problem is saying is that you take a 10 Newton object, right? And we're going to go ahead and submerge it in water. So if we take some tank, we're going to go ahead and submerge it in water and we weigh it. Okay, so for example, one way we could weigh it is just by taking a little spring scale, attaching it here. Another way we could measure it, say, is put a little scale at the bottom, measure it, right? So it's a scale down here. So either way, you're going to solve the problem the same way. So the first thing we do is go ahead and draw our free body diagram. So this is going to be 10 newtons coming down. And then this one says it's 8 newtons in water. So that means the spring scale, in other words, is going to measure 8 newtons. Or if you look at it this way, the scale at the bottom is going to measure 8 newtons. Either way, the net force, or the kind of the force in between here, there must be another force pushing up. We call that the buoyancy force. And that's simply the answer. It's going to be the difference between those two. Okay, you should get 2 newtons for that force. So how do we find the volume then? Well, remember the equation for buoyancy is rho. Now this is going to be rho of the fluid, okay, not of the object. So it's the density of the fluid times little g times the volume submerged. So remember, this is how much of the volume is underwater. Now in this case, since the whole thing's underwater, then we're just going to use the entire volume, or that's going to find the entire volume for us. So for this question, we are looking for the volume submerged, right? Because again, it's fully underneath the water. All right, so just go ahead and substitute in. So we got 2 newtons for the buoyancy. We have the density of the fluid, which was water. So this is going to be 1,000. And then the little g is little g, okay, 9.8. Or, if you want, you could go ahead and just use 10 for that. So when we calculate that, we get a volume submerged. This is going to be about 2.0 times 10 to the negative 4th meters cubed. All right, last question is now we're going to look for the density of the object. So the density of the object, we're just going to use the mass of the object divided by the volume of the object. So again, the volume submerged is going to be the same since it's entirely underneath the water. The mass of the object, well, they gave us the weight in air, right? And that's equal to simply mg. So this should be, what, the weight divided by g times VO. And we'll just go ahead and solve that. So the weight was 10 newtons. This was the weight in air divided by 9.8. Or again, you could probably just use 10 there. And our V submerged was 2 times 10 to the negative 4th. Right, go ahead and solve that, and you should get 5,000 kilograms per meter cubed. Make sure your answer makes conceptual sense. Since it did sink, it should be greater than 1,000, right? In fact, if you look at this number, this is exactly 5 times greater than water. So we'd say it has a specific gravity of 5. But check this out. The weight of the object was 10 newtons, right? The weight of the object was that. And the buoyancy force was 2 newtons. 10 divided by 2 equals 5. Is that just a coincidence? Actually, no. So if you do a little combining of equations here, you should be able to derive this relationship. So I'll just leave that to you to go ahead and try to do that. One last question, and this I guess is another final question I'd like you to try, is what would happen if we just let this thing, we held it right here, and then we just let it go. So we dropped it. Okay, well hopefully you'd see it's going to accelerate, right? There's going to be some acceleration as it goes down. But how much is it going to be? So I'll leave that question again for you. See if you can calculate the acceleration of this object as it falls through the water. It may be a conceptual question. Does that change? Does it increase as it goes down, the acceleration, or is it a constant acceleration? So I'll leave that for you. Go ahead and try to solve it. You should get about 8. Okay, so when you solve it, you should be getting about 8.